Imagine a vast cloud of gas and dust stretching across the cosmos like a celestial canvas. This was the Solar Nebula, the birthplace of our solar system, a swirling mass of potential and possibility. It was a chaotic place, filled with the remnants of dead stars, each contributing to the nebula's complex makeup. Within this swirling mass, gravity began its work, pulling particles together and setting the stage for creation. The Solar Nebula wasn't just an empty cloud. It was a dynamic environment teeming with activity. It contained the building blocks of planets, including hydrogen, helium, and heavier elements like iron and silicon, all essential for the formation of celestial bodies. These elements, forged in the hearts of long-gone stars, would become the raw materials for Earth and everything on it, a testament to the life cycles of stars. The Solar Nebula was a dynamic place, with particles constantly colliding and sticking together, driven by the forces of nature. Over millions of years, this process, known as accretion, began to form larger and larger objects, eventually leading to the creation of planets and other celestial bodies. The stage was set for the birth of a star and its planetary system, a cosmic dance that would give rise to our very own solar system. Gravity is a powerful force, one of the fundamental interactions that govern the universe. It is the invisible hand that orchestrates the grand dance of celestial bodies, pulling them together and shaping their destinies. In the vast expanse of the Solar Nebula, gravity drew in more and more gas and dust towards the center, creating a swirling disk of material. This was the early stage of our solar system's formation, a chaotic yet beautiful process. As the cloud contracted under its own gravity, it spun faster and faster, much like a figure skater pulling in their arms to spin more rapidly. This increase in rotational speed was a crucial step in the formation of our Sun. This spinning disk, with its dense, hot center, marked the beginning of our Sun. The proto-Sun, as it is called, was a bright and intense focal point in the midst of the swirling chaos. The temperature and pressure at the center of the disk continued to rise, driven by the relentless force of gravity. This intense heat and pressure were necessary for the next critical phase in the Sun's formation. Finally, the conditions reached a critical point. The immense pressure and heat at the core of the proto-Sun set the stage for a monumental event. Hydrogen atoms, forced together under immense pressure, began to fuse into helium. This nuclear fusion process released a tremendous amount of energy, igniting the proto-Sun into a full-fledged star. The Sun, our very own star, was born. This brilliant new star would become the heart of our solar system, providing light and warmth to the planets that would soon form around it. This event was a defining moment for our solar system. The birth of the Sun set the stage for the formation of planets, moons, and other celestial bodies. The Sun's intense heat and gravity would shape the destiny of everything that remained in the surrounding disk. Its powerful gravitational pull would gather the remaining gas and dust, leading to the formation of planets. The stage was now set for the formation of planets, including our own Earth. This grand dance of gravity and matter would eventually lead to the diverse and dynamic solar system we know today. While the Sun blazed at the center, the remaining material in the disk continued to swirl around it. Dust grains, drawn together by electrostatic forces, clumped together, forming larger and larger particles. This process, known as accretion, is the key to understanding how planets formed. Over millions of years, these particles grew into planetesimals, small, rocky bodies kilometers across. Like cosmic vacuum cleaners, these planetesimals attracted more and more material, their gravitational pull increasing as they grew. In the region where Earth would form, one planetesimal began to dominate, pulling in its neighbors. This was the birth of Proto-Earth, a hot, molten ball of rock, still far from the planet we know today. The young Earth was a chaotic place. It was constantly bombarded by asteroids and comets, remnants of the planet-forming process. One impact, however, would change everything. Scientists believe that a Mars-sized object named Theia collided with Earth in a cataclysmic event. This is the giant impact hypothesis. This impact was no glancing blow. Theia slammed into Earth with incredible force, vaporizing itself and blasting molten rock into space. This debris, caught in Earth's gravitational pull, gradually coalesced, forming our moon. The impact had a profound effect on Earth as well, potentially tilting its axis and creating the seasons we experience today. Section 5: Cooling and Coalescence. Earth's crust and oceans emerge. After the chaos of its early years, Earth began to cool. The molten surface gradually solidified, forming a thin, primordial crust. Volcanic activity was rampant, releasing gases from the planet's interior into the atmosphere. This outgassing played a crucial role in shaping Earth's future environment. As Earth cooled further, water vapor released by volcanic eruptions began to condense in the atmosphere. Torrential rains fell upon the young planet, filling the low-lying areas. Thus, Earth's first oceans were born, setting the stage for the emergence of life. Section 6: The Breath of Life, the Great Oxygenation Event. The early Earth's atmosphere was very different from what we breathe today. It was rich in nitrogen, carbon dioxide, and other gases, but oxygen was scarce. This began to change with the emergence of a new form of life, cyanobacteria. Cyanobacteria, also known as blue-green algae, were among the first organisms to evolve photosynthesis. This process uses sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. Over millions of years, cyanobacteria released vast quantities of oxygen into the atmosphere, dramatically altering Earth's chemistry. This event, known as the Great Oxygenation Event, paved the way for the evolution of oxygen-breathing life, including ourselves. Section 7: A planet-transformed life finds a foothold. The rise of oxygen in Earth's atmosphere had profound consequences. It led to the formation of the ozone layer, which shielded the planet's surface from harmful ultraviolet radiation from the sun. This protection was crucial for life to move out of the oceans and colonize the land. With a more stable environment and a protective atmosphere, life on Earth began to diversify. From single-celled organisms, more complex life forms evolved. The oceans teemed with a variety of creatures. Plants took root on land and animals followed, eventually leading to the incredible biodiversity we see today. Section 8: Earth's Everlasting Evolution, a Dynamic Journey. Earth's story is not one of stasis, but of constant change. Continents have shifted, drifting apart and colliding over millions of years. Mountains have risen and eroded, sculpting the landscape into the majestic peaks and valleys we see today. And ice ages have come and gone, leaving their mark on the planet's surface. Life itself has been shaped by these changes, adapting to new environments and evolving over time, with extinctions paving the way for new species to emerge. Each era bringing forth a new chapter in the story of life. From the fiery chaos of its birth, when volcanic activity was rampant, to the vibrant planet we call home, teeming with life and diverse ecosystems. Earth's journey has been remarkable, a testament to the power of natural forces and the resilience of life. As we continue to learn more about our planet's history, through the study of geological samples and the layers of Earth's crust, we gain a deeper appreciation for the delicate balance of conditions that allowed life to flourish, understanding the intricate interplay of factors that sustain our world. And we are reminded that Earth's story is far from over. It is a tale of continuous evolution, with each moment adding a new layer to its rich history. It is a dynamic planet, constantly evolving, shaped by natural events like volcanic eruptions and earthquakes, and its future is yet to be written, holding endless possibilities.